So today we're learning how to evaluate inverse trig functions. So when we're finding an inverse, so like for inverse of a trig function, we'll see like inverse sine, etc. So this symbol means inverse. This sometimes is also referred to as arc sine. Okay, so these are two notations that mean the same thing. So we're finding the inverse or arc trig function. We're finding the angle or angles that give us the trig value in the argument. So what's in the parentheses here would be our argument. So say, for instance, if I wanted to find what angle or angles give me a value of positive 1/2 for sine, this is how I could write that. So this is inverse sine or arc sine. These mean the exact same thing. They're just two different types of notation that you might run into. Okay, so let's work through some of these. Find all solutions between 0 and 360 degrees and 0 and 2 pi. List all answers in both degrees and radians. So that's going to help us kind of just work with both of them and get used to converting between radians and degrees even more. Okay, so in fact, let's do that exact problem. Let's find the arc sine or inverse sine of positive 1/2. Okay, so this is the argument, positive 1/2. I'm trying to figure out where on the unit circle the y coordinate, remember sine is the y coordinate of the unit circle, is positive 1/2. Now my goal is to be able to figure that out without looking at the unit circle. Now if you have a unit circle in front of you, yes, you could look up where is my y value positive 1/2? What are all of the angles? Okay, so since we're between 0 and 360, we're talking about a full unit circle. And we're talking about where sine is positive. Okay, so first of all, sine is positive in the top two quadrants. It's positive here where they're all positive, and in quadrant 2, right? So both of these quadrants is where sine is positive, the y coordinate. Now, how do I get 1/2 without a unit circle in front of me? So if we remember, when we're using our left hand trick, that sine is what we count on the right. So think about, in my format here, square root of blank over 2, what would I need to put in here? How many fingers would I need to have left up on the right? So to get to a value of 1/2, we would need to leave one finger up. So if I was leaving one finger up on the right, that means I would need to fold down my ring finger, or 30 degrees. And what this tells us is that we are 30 degrees away from the x-axis in both of these quadrants. 30 degrees away from both of them. So in quadrant 1, that is a 30-degree angle. In quadrant 2, though, think an easy way to figure this out, remember this would be 180. So we'd have to go back 30 degrees, and that would correspond to 150. So there are two places on my unit circle where sine is positive 1/2. 30 degrees in quadrant 1 and 150 degrees in quadrant 2. Now to convert these to radians, remember to think this is 180 or pi divided by 6. There's my radian measure for 30 degrees. And 150 in fact is that measurement, 30 degrees times 5. So it's 5 times, I don't know why it keeps circling my bottom there, times pi 6. It is 5 pi sixths radians. And so those are our solutions. There are two answers. We've just given those two answers in both radians and degrees. Okay, let's try another one. What about the inverse cosine of positive 1/2? So now we're looking for where is the x-coordinate. Remember, cosine is the x-coordinate on the unit circle, positive 1/2. So first of all, our argument is positive, so let's figure out where is cosine positive. Well, it's positive in quadrant 1, where they're all positive. Remember, all students take calculus. And in the fourth quadrant, right, for calculus. So it's positive when we're to the right of the y-axis. That makes sense. So in quadrant 1 and quadrant 4. And now remember, cosine, we count fingers on the left. So to get to a value of 1/2, think about how many fingers would you need to leave up in here. We would need square root of 1. So we need to leave one finger up on the left, meaning 60 degrees is on the finger we would have to put down, right, our index finger there. So we are 60 degrees away from the x-axis in both of these quadrants. So in quadrant 1, that corresponds to 60 degrees directly. In quadrant 4, think of, for me, the easiest way is probably to go back 60 degrees from 360, which would correspond to 300. Now, to convert these both, so these are our two answers. We just want to convert them both to radians as well. So 60 is 180, or pi, divided by 3. And 300 is just a multiple of this. So it's pi thirds. It's actually 60 times 5. So 5 pi thirds radians is the same as 300 degrees. So these are our two answers. There were two angles that gave us a cosine value of positive 1/2. Okay, let's try a few more of these. So arc tangent, notice now they're using the arc notation, but they could have also called this the inverse tangent of 0. Again, these mean the same thing. So where is tangent 0? So now remember, we're not using cosine or sine directly. We need to remember some of these values. So tangent is 0 at 0 degrees. In fact, anytime we're on the x-axis. So where is tangent 0? It's 0 here, and it's 0 here. Right? In fact, we're not really in any of the quadrants. We're kind of on the border here. So that corresponds to, in fact, 0 degrees and 180 degrees. Now typically, and I didn't write that in there, typically our angle is really between 0 and 360, where we exclude 360. So I should have written the requirements more like this. Apologies there. So we're actually going to use 0 rather than 360 here. So 0 degrees and 180 degrees, which corresponds to 0 radians and pi radians. Okay, let's try our next one. Inverse sine or arc sine of negative root 2 over 2. Okay, so we're talking about sine, and notice that it is negative. So sine is positive in the top two, right, the y-coordinate, but it's actually negative down here. So we're actually in quadrant 3 and quadrant 4. So now I know which quadrants we're in. Let's talk about how to get to root 2 over 2. So again, sine is, we're kind of counting fingers on the right. So I know I'm going to need to leave a two fingers up, right, to get to root 2 over 2 on the right. Which means the finger we're going to need to put down is our middle finger, which corresponds to 45 degrees. So we are 45 degrees away from the x-axis in both of these quadrants. So I could think of this as 180 plus 45 for quadrant 3, which is 225, and 360 minus 45, which ends up being 315 in quadrant 4. Now note these are both multiples. 45 degrees is pi fourths radians. And we need to go 1, 2, 3, 4, 5 of those to get down here. And that makes sense. That's actually just one more than 4 pi fourths or pi radians. And then we're going to need to go, that's 5, 6, 7 pi fourths. And that makes sense. That's 1 pi fourth less than 2 pi in radians. So again, we end up with 2 solutions. Okay, a lot of these have two solutions, not all of them. I'll do one at the end of this slide that only has one. So let's try our next one. Inverse tangent of square root of 3. So if you remember your tangent values, those are 0, root 3 over 3, 1, root 3, and undefined. So those are the 5 tangent values you're supposed to have memorized. So first of all, we're talking about tangent, and this is a positive value. So let's figure out where tangent's positive. In the first quadrant, where all 3 are positive, and in the third quadrant. Now, root 3, that value itself is 60 degrees. That would be the finger that corresponds to our value. So we are 60 degrees away from the x-axis in each of these quadrants. So 60 degrees itself in quadrant 1, And 180 plus 60, or 240, so we're 60 degrees beyond 180 here, right? 240 in quadrant 3. So the 60 is 180 divided by 3, so pi thirds radians. And this is 60 times 4. So we're going to take our pi thirds, multiply it by 4. 4 pi thirds is our radian measure for 240. Okay, before we go to the next one, let's say I gave you one that's only going to have one answer here. What if I asked you what is the inverse sine of -1? Right, so just an extra example. Sorry, the numbering will be off in the video here. Now sine itself at -1, if I think of sine as the y-coordinate, right, if we use this top figure, or I guess I make my own all students take calculus. Sine is -1 down here at the bottom, right? This point is 0, -1, and that's the sine of -1. There's only one place where sine is -1, and that's at 270 degrees, which is 90 times 3, or pi halves times 3, 3 pi halves. So that would be our solution for that one. So sometimes you do get ones that only have one solution, right? There's only one place on the whole unit circle where between 0 and 360, sine is -1. Okay, let's try a couple more here. Arc cosine, or inverse cosine of -1. Ooh, I guess I didn't need that extra example, did I? So try that one out really quick then, since I just did the inverse sine of -1. What do you think our answer is this time? Okay, so if you tried that out, here, remember cosine is the x-coordinate. This is the only place on the unit circle where cosine, the x-coordinate, is -1. And that corresponds to 180 degrees, or pi radians. And that's it. That only has one solution there. Okay, so note, of course, if your value in here for sine or cosine is 0 or 1, that we're going to be on an axis, not in a quadrant. So it's easier to think about where that point would be. Okay, here's another one. Think about this one for a second. Where is sine +2? So sine is the y-coordinate, right? I mean, if I have my all students take calculus. Well, let's see. Sine here is 0, right? The y-coordinate there is 0. Here it's 1. And then it gets lower and lower and lower. And eventually you would get down here to -1 being the lowest point, right? Where is sine 2 on the unit circle? And the answer is nowhere. Sine's value has to be between -1 and 1, including those two values, but it cannot go beyond them. So this is actually undefined. Sine is not defined for any value between 1 or -1. And that's the same for cosine. Now tangent can go beyond 1 or -1, but not sine or cosine individually. Okay, so here's a few to try out. I didn't put the hand figure in here. The all students take calculus. You're supposed to just be doing that on your hand anyway, but you can quickly draw your own all students take calculus chart. Figure out where these things are negative. Actually, it looks like a lot are negative, or 0. And then I threw in a challenge one for you down here. So we're not going to do a ton of the inverse ones, like, reciprocal inverses, like inverse secant, inverse cosecant, inverse cotangent. But here's one that's not terribly difficult. So see if you can figure that one out. Okay, so pause the video now, try these out. I'm just going to put final answers, and then we'll go over questions on these at the beginning of class. All right, so here are the final answers. It looks like pretty much all of them had 2 answers in this section. And then there's the little bit of help for the challenge problem at the bottom. If you have any questions on how to get to these values, or if you didn't get these, make sure to have questions ready to go at the beginning of class.